To integrate inverse x over x from 0 to 1, first we're going to use the RDI method. Integration by part, we're going to differentiate inverse x and then integrate 1 over x. To integrate 1 over x, you get L1x. Just another absolute value, because we are doing an integral. In the DNI method, and then to differentiate inverse x, you get 1 over square root of 1 minus x squared. So this time that you get inverse sine x times L1x. You're gonna put 0 and 1 into it later, and then subtract the integral of this L1x over square root of 1 minus x dx. Don't forget to plug the limit. And then to do this, if you plug 1, you get inverse sine 1 is pi over 2 times L1 is just 0, so over you get 0. And that's our second part. If we plus 0, because this is the integral from 0 to 1, so if we plus 0, this is equal to negative infinity, L1 0. And then inverse sine 0 is equal to 0. Then 0 times inverse, 0 times negative infinity is an indeterminate form. So we're gonna do more work. Now integral, we're gonna do a limit that x approaches to 0 plus. Because later we're gonna use our last bit rule, so I'm gonna put L1x in the denominator. 1 over L1x, inverse x over 1 over L1x. So we get the original back. And then do our last bit rule, you get limit at x approaches to 0 plus. And this is equal to 1 over square root of 1 minus x squared over, first you get L1x squared. And then subtract the derivative of this, it's just 1 over x. So overall you get so this is just equal to 1 over square root of 1 minus x squared. Then put a negative and then subtract our 1 over x times L1x squared. So you see, I'm not going to do L1x here. Let me just do a sine x, because we can get rid of the L1 here. So L1x over inverse x, what over 1 over inverse x. So we can cancel our L1x here. The L1x won't repeat, so you can get this is 1 over x, and then this is, first you square that, inverse sine x squared that, and then do a derivative inside, you get negative 1 over square root of 1 minus x squared. So this is just equal to 1 over x what, negative, and then 1 over square root of 1 minus x squared times inverse sine x squared. So this is just equal to what? Just switch the order, you get negative 1 over x times inverse sine x squared over x, right? So if you plus 0, and this is what? 0. 0 over 0 situations once again. So do this once again. To get rid of the x in the denominator, you will get limit x approaches to 0 plus, and then negative times 1 over x squared times 2 times inverse sine x over square root of 1 minus x squared, and then plus inverse sine x squared, and then multiply by the derivative of this. First you get 2 times inside, multiply by term inside, you get negative 2x. So this and this we cancel each other out. You get limit at x approaches to 0 plus. And then what's this? Oh, it should be negative. Let me just put a negative outside. Negative. And then 2 times inverse sine x. 2 and 2 they cancel each other out, so you can get negative x over 1 minus x squared. If you put 0, you get 0, and then this over you just get 0. Negative 0 is just 0. So this answer is just 0. And then to do this is really easy. It's our substitution. The x is equal to sine theta, dx is equal to cosine theta. So what is our theta? Our theta is just inverse x. If you put x is equal to 0, and then inverse sine 0 is just 0, and then inverse sine 1 is just pi over 2. So we can get square root of 1 minus sine square theta times cosine theta d theta, and then ln(x) is just ln of sine theta. Right. So square root of 1 minus, and then 1 minus sine square theta is just cosine square theta. Take a square root, and then this and this will cancel each other out. And then this integral that will tell you the integral of ln sine theta d theta from 0 to pi over 2. This is equal to negative pi over 2 ln 2. This is a really famous integral. And then the answer is just pi over 2 ln 2. That's it.